Today we'll talk about why our muscles don't grow the way we want and what the mechanism inside of our muscles that inhibits our potential growth is. Okay, so this is not medical advice, this is entertainment only. For those with a medical condition, please consult with your physician. So oftentimes we're trying to train very, very hard in the gym. Okay, we're going to failure, we're doing supersets, we're doing drop sets, and our basic understanding is the more we damage the muscle, the more we grow in response to this damage. Okay, so this is true to a certain extent. Let me explain a little details about this theory. Okay, let's start from the beginning. Our goal is muscle hypertrophy. Okay, so the growth of muscle tissue. So there's several ways to induce muscle hypertrophy. There's mechanical tension, there's muscle damage, and metabolic stress. Okay, metabolic stress is basically the accumulation of molecules that will trigger muscle hypertrophy cascades in our body. Okay, and muscle damage is straightforward. We're inducing micro tears in the sarcomeres. The sarcomeres are the smallest units of our muscles, made of actin and myosin pulling against each other, and these damaged little micro tears in the muscles in the sarcomeres will actually lead to muscle growth in the long run. Okay, and muscle hypertrophy can also divide it into two different types. Myofibrillar, so when you talk about myofibers, what I was just saying, inside of the sarcomere with actin and myosin proteins, and these pull against each other, and this is myofibrillar hypertrophy when these elements become bigger and stronger. But we also have sarcoplasmic hypertrophy. So sarcoplasm is all the liquid that's floating around, okay? And this is more a volume enhancing hypertrophy. It is not so much related to strength as myofibrillar hypertrophy. Okay? If you want an easy to understand example, myofibrillar hypertrophy would be something seen more in powerlifters. It is really related to strength. Okay, the actual protein is growing bigger. And sarcoplasmic hypertrophy would also be seen in a more bodybuilding type of training, where we have a volumization effect of the liquid, basically, of the cells, and not so much increase in strength. Okay, but these often always happen to a certain extent together. Okay, so just a percentage of which is different in the way we train. So we were talking about muscle damage and how this can actually help us muscle grow, but also how it can inhibit our muscle growth. Okay, so now it is the important part to understand. So muscle damage is an important factor to trigger muscle hypertrophy. Okay, when we move our muscles, we release calcium. Okay, and this calcium is crucial for the movement of our muscle. And we release a protease called calpain. And calpain is basically remodeling our muscles. It's a protease. Okay, protease, ase means breaking down, and protein means protein. Okay, so this molecule is breaking down muscle tissue to remodel it. Okay, so when you're working hard, calpain is released, and then the muscle is broken down. We have micro tears in the sarcomeres, and then it's remodeled, and hopefully remodeled in a way that it gets bigger and stronger. Okay, that's the whole goal of releasing calpain. And the increased calcium release also creates increased calpain release. But here is the thing. Okay, so the micro tears, so damage we have in our sarcomeres, will release calpain, and it will adapt and accordingly repair. It will repair in a way that it grows stronger and bigger. Okay, and this will ultimately lead to hypertrophy. Here comes the catch. If we release too much calcium, we release too much calpain, the molecule that is breaking down the muscle tissue. And this leads to chronic damage to the muscle. Okay? So if we release too much calcium, too much calpain, then the muscle hypertrophy mechanism is basically turned around and you're losing muscle. Because too much of this remodeling molecule is released, too much calpain is released, and we are basically losing muscle because we are using excessive amounts of calcium, okay? So that's the important point to understand. So how does this relate in real life training? So we know that we have to train hard. We know that we have to train to failure to actually damage the muscle, okay? But sometimes we tend to overdo it, okay? When we reach muscle failure, we already released a lot of calcium, we release calpain, our muscles ready to get remodeled and get bigger, but then we do another forced 1 or 2 reps, or we do a drop set, or we do a superset. And this basically releases so much calcium releasing calpain that the ability, capacity of remodeling the muscle is impaired, and we actually cannot grow bigger muscles, okay? So there's a fine line between training to failure and overtraining, okay? That's important to understand, okay? Of course, if some athletes use performance enhancing drugs and other methods, or are genetic freaks, they will grow no matter what they do, okay? So please don't say, okay, this and that bodybuilder is growing just fine by doing a 4 reps or a drop set. That might be true, but I'm talking about an average individual without PEDs. If you really wanna maximize your growth potential, it is important to release good amounts of calcium and calpain to remodel the muscle, to make it grow bigger from the microtubules, but excessive amounts of calcium trigger excessive amounts of this protease, the protein breaking down molecule calpain, which will then damage the muscle and prevent it from growing, okay? So that is the key take-home message here. Training hard is important, but overtraining can be too much because of this calcium calpain cascade, which inhibits muscle or maximum muscle growth. I hope this was helpful, and if you have any comments, please let me know in the comment section down below, and I will see you in the next video. Thank you for watching.